Question number 24, we have the series n squared times x to the power n, so that's our power series part, divided by 2 times 4 times 6 all the way up to 2n. And making note that this denominator is going to behave like n factorial. So it's not the same as n factorial, but it will behave similarly to n factorial. So I've set up our ratio test here, where we put n plus 1 in the numerator, and we have the factorial-like expression in the denominator. And because we have n plus 1 terms in the numerator, it's important to note that, I'm just gonna put a fraction in here. Because we have n plus 1 in the numerator, it's important to note that we have this extra 2n plus 2 multiplier in the denominator of that red fraction. Okay, so we have the same number of terms all the way up to 2n, and then we have one more term which is going to be 2 bigger than that last term. Okay, once we establish that, we're going to group some of our terms. So I'm going to group our n plus 1 squared with the n squared. I'm going to group the factorial parts of this. So I'm going to highlight that in green here. I'm going to group the factorial parts of this. And making note that I have 2 times 4 times ... all the way up to 2n in the numerator. And in the denominator, I'm going to have the exact same terms. So every one of these terms is going to cancel out all the way up to 2n, but we have that extra 2n plus 2 multiplier in the denominator. Okay, so we can see that everything's going to cancel out here. We're going to have the 2's, 4's cancel, the 2n's are going to cancel. We're going to be left with that 2n plus 2. And with the x powers, we're going to have x to the power n plus 1 divided by x to the power n. So that's just going to give us x to the power 1. And this is going to be less than 1. Now looking at these parts, I'm going to apply my limit. The limit of n plus 1 squared over n is just going to be 1. For this factorial part, we just have this leftover term 2n plus 2. And then we have the times 1, so times x. Now that part, this part here, when we apply our limit, maybe I should have done this. I'll do this properly, so I should keep that as we haven't applied our limit yet. So the limit as n approaches infinity, we have n plus 1 squared over n squared. We have that leftover 1 over 2n plus 2. That's going to go to 0. We have that x, and that's going to be less than 1. Now when we apply our limit, the n plus 1 squared over n squared becomes 1. That green part now, we're dividing by infinity, so this becomes 0. And so what that means is we have an infinite radius. And our domain, or our interval of convergence, is going to be from negative infinity to infinity.